Hey guys, so today we're going to be talking about measures of center of discrete random probability distributions. So this is a pretty wordy sort of title, but basically what it means is we're going to be talking about the mean, the median, and the mode in relation to probability distributions and being able to calculate these, and also, when I say mean, also the expected value, which are interchangeable terms. So if you're not quite sure about the mean, median, mode, you can't quite remember at all, then I would suggest looking at some other videos or just looking up the quick definitions and reminding yourself before continuing the video, as this will relate more to probability distributions where you have a table with some different values and you have to calculate the different three. So, the typical form that you're going to be using this question is you have x, so I'm just saying they're basically the outputs. And you could have the values, let's say 1, 3, 4, 8, and 10. So these are all different outputs from whatever it could be. It could be anything like number of goals scored, number of marks on a test. There could be any different scenario. And then the probability of each of these occurring. So I'll just put some values in. So the probability that one occurs is 0.2, so 20%, 0.15, 0.2, 0.3, and 0.15 for 10. Now, if you remember before, there was a key theorem which I said, which is the sum of all the x's, so all the outputs. So you can sort of represent that by xi, so each of those I just represents any of the outputs, must equal 1. So it's basically saying that the probability of every different output occurring, every different outcome, must equal 1, which makes sense. So how does that apply to this? Well, it means that the probability of all these added together must equal 1. So we can just check that. So 0.2 plus 0.15 plus 0.2 plus 0.3 plus 0.15. So you can think about that's 5, that's 0.3, 0.3 plus 0.2 is 5, 0.5, sorry. So that's going to equal 0.5 plus 0.5, which is equals 1. So it works. So the question could have had an x, for example, somewhere along here. You might not have known what 0.8 was. There could have been x. So what if x equaled? You could have worked out that x equaled 0.3. So, the mean. You can think about this in the probability as the expected value. So expected value is what it sounds like. If you do a game, if it's a game, or if you play a game of soccer, the expected value is the value that you expect to get. So that's why it's called the mean, so otherwise known as the average. Because the average, let's say the average test mark is 50 out of 60. If you randomly select a student, then your expected value would be 50 marks out of 60. So if you randomly select someone, then you expect to get the average. And so that relates to this probability as well. So how do you work out the expected value from a table like this, or when they give you the probabilities of the different discrete outcomes occurring? Well, you times whatever the value is, then you times it by the probability. So the notation is a big A, and then x. So I'm just letting x be the outcome, but it could be something else. So 1 times the probability, plus the next outcome, times that probability, and so on. Now, when you've previously calculated probability, you may have added them, or the average, So the average expected value, you probably added them all up and then you divided by the total. So you can do that because the probability of each of these are the same. And that's actually the same thing. So on the side, if you're trying to work out the average marks on a test, the expected value, you get 50, 60, and you have 70. So what you can do is you can go 50 plus 60 plus 70 divided by 3. What effectively you're doing here is you're going 50 times 1 on 3 plus 60 times 1 on 3 plus 70 times 1 on 3. So these two are equivalent. What I've done is I've separated the divided by 3 because it's when you have different numerator terms, you can always separate them and keep a constant denominator. You can't do it the other way, but you can do it when there are multiple numerator terms. And I've just changed the divided by 3 to a times 1 over 3, as they're exactly the same. So if you can see the similarity between here and up here. What you do is you have the probability of it occurring, then you have down here the probability of the different events occurring. And so with the events, these were the marks. These are equivalent to whatever you want to have up here. So you get your calculator out, or or you can do it in your head. But 0.2 plus 3 times 0.15 plus 4 times 0.2 plus 8 times 0.3 plus 10 times 0.15 equals 5.35. So if this was playing, we'll use a gambling, a money game because it's the easiest to work with. You're playing a game, some of the time you've paid to play, and then you're going to either win $1, $3, $4, $8, or $10. Your expected amount of money would be $5.35. And if you can relate this, if let's say the cost to play was $5, then you could say you would win most of the time. If the cost to play was $6, then you would lose most of the time. So a term used is called a fair game. And they might use it in different worded questions on an exam or in different questions. So a fair game means that the expected value is going to equal 0. So it means that if you play, this relates normally to money or a game similar to that, the expected value is going to be 0. So you're not going to make anything or lose anything. For example, for up here, if the expected value is positive 5.35, so you're going to make $5.35, but it costs you $6 to play, so you can sort of think about that as -6, then your expected value would be 5.35 minus 6. Now I've included this minus 6, so if you are getting a bit confused here, don't worry too much about this fair game and just worry about before with the tables and getting the expected value. This is just more some extension onto the fair game. So you now know how to calculate the expected value. You get all the different outcomes, you times them by the probability. We just saw how that relates to calculating the average, which you may have previously done. I'm now going to split up the measures of center of discrete random probability distributions into 2 videos. So we just talked about the mean, the expected value, and then the next video we'll focus more on the median, the mode, and expectation theories. So just quickly, if you wanted to work out something like that, how do you work out e to the 2x if you know e to the x? Thanks for watching, guys.